This is the solution to homework set number 10 for EE206 Circuits 1. The first problem, we're trying to find the current loops in the following circuit. The steps are: first, note that the input is 10 cosine 250t. In phasor form, that's 10 plus j0, 10 cosine, and 0 sine. The frequency is 250 radians per second, so for capacitor, the impedance is 1 over j omega c. So the capacitors become minus j 400 ohms. Now write the loop equations just like we did before. Around loop I1, it's minus 10 plus 100 I1 minus j 400 times I1 minus I2. Around loop I2, around loop I3, write your loop equations. And this is what you should get. Around loop I2, I have minus j 400, I2 minus I1, plus 100 I2, minus j 400 times I2 minus I3, likewise for loop 3. That gives you three equations, three unknowns. To solve, group the terms, place in matrix form, and then solve. Here MATLAB is really useful because we're using complex numbers. They're kind of painful to solve by hand. MATLAB doesn't care. Just input the matrix with complex numbers. Here's your B matrix. That's actually 10 volts. Got a typo here. The current is the inverse of A times B. So there's your current. And what that means is the real part is cosine minus j is sine. So I1 is 0.03 cosine 250t minus 0.03 sine 250t. Likewise for I2 and I3. So that's problem number 1. On problem number 2, same idea. Here's a circuit. The input is 4 minus j5. Note the sine and cosine are the same frequency, so I can group them together. The capacitor becomes minus j40. Inductor becomes j2.5. This capacitor is minus j80, and this one's j5. Now write your loop equations just like we did before. That will give you this for the three loop equations. Run loop I1, I2, and I3. Again, the inductor just looks like a resistor, just happens to have a complex impedance. To solve, group the terms, place in matrix form. Now solve in MATLAB. So now the current is the inverse of A times B. Wind up with a complex number. What the complex number means, the real part is cosine, complex part is sine. And here if I express it in milliamps, I just multiply by 1000. So that's 0.209 cosine 250t minus 0.043 sine 250t in amps, or this in milliamps. Problem 3, with voltage sources. The trick with with op amps. The trick with op amps is the node equation at the output is V plus equals V minus. You'd like to write the node equation V4, but you can't because I have no idea what this current is. The op amp's an active device. It's outputting current. And the current is whatever it takes to force V plus equal to V minus. I can't write the node equation when one of the equations is whatever it takes. So instead you get your V3, or V3 equals V2. So for the op amp, the node equations would be the input is 0 minus J10, 0 cosine, 10 sine. The node equation at V0 is 0 minus J10. The output equation is V2 equals V3. Now the other equations at node 1, the current left, down, and right equals 0. That's this equation. At node 2, the current left and down equals 0. This equation. At node 3, the current left and right equals 0. The node equation V4, again, is right here. The node equation V4 is V2 equals V3. That gives me 5 equations, 5 unknowns. To solve, group the terms. And here what I did, I just multiplied these equations by 1000 to make the numbers a little bit easier to use. So these are the same equations in matrix form. Throw in MATLAB and solve. And that's what you get. So again, the real part is cosine, minus j is sine. So these are the voltages. If I change the problem, change the input to 12 cosine 200t, now the input is 12 plus j0. The frequency changed, so the impedance of the capacitors changed. This is 1 over j omega c. Now write the node equations just like we did before, except that now I have minus J5000 for the capacitors. Group the terms, solve. I now get a different answer. Note that the phasor form assumes the frequency. The input was at 200 radians per second. The output is at 200. So this is the output when the input is 12 cosine 200t. Problem 5 is kind of a trick question. If I put the two together, what you really do is use superposition. Pretend the input is just 10 sine 200t, solve for V4. That's problem 3. Assume the input is 12 cosine 200t, solve for the output. That's problem 4. Put the two together, I get the total input. Put the two together, I get the total output. So just add up the previous two answers, the 100 and 200, and you get the total answer. So that is homework set number 10 for EE 206.